Hello friends, welcome to chemistry interview. I hope you are doing well. Today I am going to discuss about the some important question which is based on the point group. I have given in last group theory video. If you have done, please check it out. This unit is very important for your entrance exam like CSIR-NET, JRF, BARC, GATE, TIFR and other competitive exam. Every year they ask 8 to 10 marks question from this unit. So please take it seriously and try to do your best. Okay, let's see. My name is Chandan. So I have given in the last video first question that the symmetry point group of propyne. Can you draw the structure of propyne? Yes, you can do it by yourself. If you have done, please check it out. So this is the structure of propyne, you can see here. And what are the symmetry element present here in this molecule? Can you identify? Yes, you can do it. We have already discussed about the symmetry element, how to identify. Okay, so let's see. There is identity and 2C3 and 3 sigma V, right? We know that Cn axis can be operated into n minus 1 time. So C3 axis will give C31 and C32, right? You can see here C3 axis which is passing through the origin of the molecule. Yes, and there is 3 plane of symmetry, which is vertical plane of symmetry. You can see here plane of symmetry is parallel to the principal axis of symmetry. So what is the combination of this point group? Symmetry element identity Cn plus n sigma V. So it will give CnV point group, that is C3V point group for this molecule. What is the order of this point group? 6. You know that order of point group is number of symmetry element present in the molecule. There is 6 symmetry element present, so order of this point group is 6. Hence option B is the correct answer, right? If you have done, please check it out. Next question is that the product of sigma xy into S4Z. S4Z is the fourfold improper axis of rotation around the z axis and sigma xy is the deflection in the xy plane. This question comes from NET December 2014 and similar question they asked in BARC 2019. If you have done, please check it out. Let's see. S4Z can be written as C4Z into sigma xy. We have already discussed about this. Okay, so axis x1, y1, z1 by operating sigma xy plane, you know that x1, y1 will remain same and z axis will be reflect. Okay, so it will give x1, y1 and minus z1, right? Can you see here in this figure? X1, y1, z1 give x1, y1 minus z1 by operating sigma xy plane. Now S4Z equal to C4Z into sigma xy, right? So by operating C4 along z axis, it will give minus y1 x1 minus z1 followed by sigma xy plane, it will give minus y1 x1 z1. You can see here in this figure, by operating sigma xy plane, it gives x1, y1 and minus z1. X axis and y axis remains same and z axis will reflect. Okay, again by rotation C4 axis along z axis, that means 90-degree rotation. You can see here by rotation 90-degree, it will give minus y1 x1 and minus z1. You can see here x1 is replaced by minus y1 and y1 is replaced by x1. Again by operating sigma xy plane, you can see here x axis and y axis will remain same, so minus y1 and x1 and z axis will reflect, so it will give minus z2 plus z1. So minus y1 x1 and minus z1 by operating sigma xy plane, it will give minus y1 x1 z1. So you know that S4Z equal to C4Z into sigma xy. So we know x1 y1 minus z1. By operating s4z, it will give minus y1 x1 and z1. Similarly, if you are operating C4 along z axis on x1 y1 z1 axis, it will give minus y1 x1 z1. Hence we can say that x1 y1 z1 by operating sigma xy plane into s4z, it will give minus y1 x1 z1. Therefore, sigma xy into s4 along z axis, it will give C4z. It can be shown as the following transform. Therefore, option A is the correct option, right? Next question is the product of C2x into sigma xy. C2x is the two-fold rotation axis around the x axis, okay, and sigma xy is the xy mirrored plane. This question comes from NET June 2014. If you have done, please check it out. If you don't, please write down, okay. We know that when we operate C2x along sigma followed by sigma xy plane, we will get sigma xz. Let's see, x1 y1 z1 is the coordinate axis, okay. By operating C2 along x axis, you will get x1 minus y1 minus z1, right, and followed by sigma xy plane, it will give x1 minus y1 and z1. So x1 y1 z1 by operating C2 along x axis into sigma xy, it will give x1 minus y1 and z1. Hence x1 y1 z1 by operating sigma xz plane, it will give x1 minus y1 and z1. You can see here C2x into sigma xy, it gives x1 minus y1 z1, and by operating sigma xz plane, it will give same x1 minus y1 z1. Therefore, we can say that C2x into sigma xy equal to sigma xz. Therefore, option A is the correct answer, right? Next question is the symmetry point group obtained by adding symmetry operation sigma h to the point group C4 is. This question comes from NET June 2016. We know that combination rule. What are the combination present? What is the point group of the molecule? So as we know that the combination of Cn plus sigma h, it will give CnH point group, right? So if you are adding sigma h to the C4 axis, you will get C4H point group. Hence option B is the correct answer. If you have done, please check it out. Thank you for watching. If you have any problem in this question, let me know. We will discuss it, okay. Rest of the topic I will cover in the next video, okay. Please don't forget to subscribe my channel. If you have done, very good. If you don't, please do it and stay with me. Thank you.